So this was the line segment under which we had taken n triangles. So this is the number 1 here, 2, 3, 4, 5, 6, 7. So the length of this portion, which we actually call the projection of this line segment. Yes. Anybody saying something? Okay. So we have dropped the perpendicular from the beginning point of the line segment. We have dropped the perpendicular from the end point of this segment on the x-axis. So this portion which is between the foot of the perpendiculars is called the projection. So this projection is of length 7 minus 1, that is equal to 6. What we did, we made 1, 2, 3 and so on. This is kth number rectangle, this is nth number. So we have divided the area into n equal parts. I mean n parts of equal width. Heights are different, so areas will be different, but the widths are equal. That means the measurement along the x-axis of each rectangle is the same. So we have divided this length, which is 6, into n equal parts, and each equal part we have called h. So the number 1, after this is the length h. So this number is 1 plus h. Then this number is 1 plus 2h, and so on. Like this number is 1 plus 3h. We have these numbers which we can call the variable x. The values of variable x are like 1, 1 plus h, 1 plus 2h, and so on. The last is the nth triangle. Because this is an AP, I put the questions in yesterday's quiz. The common difference of this AP is h. And so the last or the nth term is 1 plus n minus 1 times h. That is a plus n minus 1 times b, this formula. One question was that if k is any counting number between 1 and n, then what is the kth term? So kth term of this AP is similar to the nth term. What is the difference? Is in the nth term, the value of n is just n. In the kth term, its value will be k. So in between any term is the kth term. So this is of the form this. I hope this is clear. So this point has the value 1 plus k minus 1 times h. I hope this point is clear to all.
Sir, yes.
Then second thing we did was to find the equation of this line segment. As you have understood this point, I am going to the next page to make that will have the same diagram there. I will be solving the equation of, I will finding the equation of the line segment. Suppose it is known as AB. In the next page I go. Suppose this segment is AB. A point has the coordinates from the graph 1, x coordinate and y coordinate is 2. So this point has the coordinates 1, 2. Whereas B point has the coordinates, this point is 7 and this is 1, 2, 3, 4, 5. So this is B is 7, 5. Assume that the equation of the line is of the form ax plus by equal to c, because we know that equation of a straight line is in a linear equation. So as 1, 2 point lies on it, that means x coordinate can be taken equal to 1 and y coordinate can be taken equal to 2. So we get a times 1, that is a, 2 times b, that is 2b, equal to c. Similarly, if we put the second point 7, 5, so we can take x equal to 7, so 7a, and y equal to 5, so this is 5b equal to c. If we solve these two equations, for that we multiply this equation by 5, multiply this equation by 2, so as to make the coefficients of b equal. We have the equations 5a plus 10b is equal to 5c. Second equation 14a plus 10b is equal to twice c. Subtract, this cancels. This is minus 9a equal to, this is 3c. That gives us a is equal to minus c by 3 on dividing by minus 9. So we had this question also in the quiz. Okay, what is 3a? So 3a was minus c. I had modified the question, but actually we need the value of a. And if we put the value of a in this equation, then minus c by 3 plus twice b is equal to c. That gives us twice b is equal to c plus c by 3. So this is 3c plus c, that is 4c by 3. So twice b is equal to 4c by 3. Cancellation of 2. This gives us b is equal to twice c by 3. So the 3b was equal to twice c. Therefore, the equation of this line can be reduced to putting the values of a and b, minus 1 by 3x plus 2 by 3y. C is also there. We can write like this, equal to c, but this c is going to cancel. This gives us minus x by 3 plus 2y by 3 equal to 1. Taking 3 LCM and taking on the right hand side, we have minus x plus 2y equal to 3. We will write it in the form y is equal to 3 plus x divided by 2. So I hope this part of the calculation is also clear to you.
Sir, yes.
So after this, I am going to the next page, which still has the same diagram, but I will be doing the final calculation there. From the previous page, we have for the kth rectangle, intermediate rectangle, kth rectangle, the x coordinate here is 1 plus k minus 1 times h. So x has the value this 1 plus k minus 1 times h. Why have we found the equation of line? Because from the equation, putting this value of x in the equation of line, we will obtain this y value. Y value will be the height of this rectangle. So that is our aim. Now, after this, we have done this. y is equal to 3 plus x by 2. Now we proceed to the next page with the same diagram. I am writing again the things here which we have found. Not all things, but the last results which we have found. And that is y is equal to 3 plus x divided by 2. Whereas the x coordinate of this point is 1 plus k minus 1 times h. I put the value of x here so that I will get this y coordinate. That means the height of this rectangle. So height of this rectangle y is found to be 3 plus x. In place of x, I write 1 plus k minus 1 times h and whole divided by 2. This is equal to 4 plus k minus 1 times h divided by 2. So the height of the rectangle is found. The width of the rectangle is simply h because each rectangle has the width h. Where again I am writing here, we will be using it. H is the length 6 divided by the n parts, from which in the end part of the calculation we will be using the value nh equal to 6. That is the thing. If you have h plus h plus h and so on n times, so n times h is how much? The total length, which is 6. This is the height of the rectangle, the width is h, so area of kth rectangle is equal to height into width. So I can write width in the beginning and height I multiply here. Now what will we do? For the first rectangle, so area of these n rectangles together, we are going to find together means we will be adding the areas of all these n rectangles. For the first rectangle, k is equal to 1. So if we put here k equal to 1, we get h times simply 4 by 2. I am not cancelling out 2 yet because all terms will be similar. For the second term, that is the second rectangle, the area will be k taken equal to 2 here. So this is 2 minus 1, so 1h. So this is h times 4 plus h divided by 2. Third rectangle, k will be 3 here. So 3 minus 1, 2. So this is h times 4 plus 2h divided by 2 and so on. For the last, that is the nth rectangle, k will be n. So this will be h times 4 plus n minus 1 times h divided by 2. What I do, why did I not cancel 2 in the beginning? In the remaining terms, we can't cancel. In all terms, we can't cancel. Rather, we can take h2 common in the denominator. So h by 2 is common. We are left with a new AP to be added. 4, second term 4 plus h, third term 4 plus 2h, and so on. The last term is 4 plus n minus 1 times h. So this was also a question I put in the quiz. Actually, I made quiz from the problems which are part of this big calculation. So if we know the first term of the AP and the last term of the AP and the number of terms of the AP, we can add the AP by this simple formula, n by 2 times first term plus last term. So this h by 2 is outside common. Then these are the sum of the n terms. So n times first term 4 plus last term 4 plus n minus 1 h. And this is equal to, see, this is nh. nh, let me write again. nh divided by 2. Inside I have 4 plus 4, 8. This n into h is another nh. And minus 1 into h means minus h. This is equal to nh is 6. So up to this point, actually calculation was done. After that, actually time was over. Now this is how much? This is 3 times 14 minus h. Right? Okay. Is there some mistake in the calculation? One mistake is there. Thank God it is toward the end of the calculation. We used this formula, but didn't use this correctly. H by 2 is there, so I have written h by 2, but I confused this 2 with this 2. This 2 is already there. This is not the part of this sum. The part of this sum will be n divided by 2. Another 2 is there, and first term plus last term. So here actually 4 is there. So 4 is there. So we will be left with 3 divided by 2. Let me erase it. Yeah. So we will be left with this 3 divided by 2 into 14 minus 7. Up to this point, everything clear? Or you can ask questions, because today we have enough time, and I want to introduce the concept of calculus now. Up to this, what was all about? It was AP, it was algebra, it was coordinate geometry, and all that, nothing else. But what we do in calculus, that I am going to introduce. So up to this point, any doubt in the calculation, Gurman?
No, sir.
Jasmeet, you can say in the chat box if you cannot convey. Yeah, if there is no, if there is any doubt, you can convey. Sukhman, Navraj,
Sir, yes.
Man. Okay, then I hope it is clear.
Yes.
Okay. What will happen if we take n to be infinitely large? Infinity we denote by this symbol in mathematics and physics also. If we take n approaching to very large value, infinite, what will be the value of h? Who will tell? H is some number like 6, which is a finite number, limited number. But if you make its infinite parts, what will be each part equal to? Man, can you guess? What will be the value of h then? Yes, Anmol? Arpan? See, if we take first of all n equal to 100, very easy calculations, then h will be equal to 6 divided by 100 means 0.06. If I take n is equal to million, million has 6 zeros, then what will happen? H will be equal to 0.000006. How small value? What will happen if n tend to infinity? H will approach to 0. H will become 0. And what happens in the diagram? You are seeing this. I enlarge the diagram. We have actually added the rectangles, but the sum of the areas of the rectangles like this. This is the area of first rectangle, second, third. We are adding all these rectangles on the way, whatever the rectangles are there, we are adding them. But what is left? The top of each rectangle is a very small triangle. The top of each rectangle is a very small triangle. That area is not included. So we are not getting exactly the area under the straight line. But if we make n to be infinitely large, that means the number of these rectangles having width very small, and number of them is infinitely large, then the tops of those rectangles will have no gaps left. No triangular areas will be left. You will be getting the sum of all those infinitely many rectangles areas equal to exactly the area under this straight line segment. I hope this is clear. This is the thing we use in calculus. Is it clear? Yes.
Sir, yes.
Now coming to the formula, what we have found the sum of the areas. We have found the sum of the areas equal to this value. So here we write as number of rectangles is taken to be infinitely large, h becomes 0. Therefore, exact area is equal to, take just h value 0 here. So this is 3 by 2 into 14. 3 by 2 into 14 means 21. Okay. And I will like to give a verification of this method. This is what the area which we have found. Fortunately, it is the simplest area, one of the simplest area to be found. It is the area of a trapezium. So if you see that this side of the trapezium is parallel to this side. This side has the length 2, this side has the length 5, and the distance between the two parallel sides is 6. We already know this distance is 6. So what is the area of the trapezium? Half into sum of the parallel sides multiply by the distance between the parallel sides. So if we make this calculation, 7 into 3, that is 21. So it means our method is correct. Yes. I
Sir,
hope.
yes.
But you will be wondering, if we could find the area of this trapezium by simple method, why we use this long method? The reason is this, that the areas under the straight line segments can be found by the method of trapezium, but area under the curve cannot be found by the trapezium method. So I will be stopping the sharing up to this, and I will be opening the page now for a curve. Wait for a minute. So I am opening the page next. So I am sharing this. Visible? I have taken a curve, this blue color curve. Actually, its formula I have taken very simple one, y equal to x square. See, when x is 0, y is 0. When x is 0, y is equal to 0 square, that is 0. When x is equal to 1, y according to this formula should be 1 square, that is 1. So this point is 1 comma 1. First point was 0 comma 0. This is 1 comma 1. And when x is equal to 2, y is equal to 2 square, that is 4. So that means this point is, here yeah, x coordinate is 2 and y coordinate is 1, 2, 3, 4. So this is 2, 4. We are to find the area under this curve. That means we want to find this area. I can, you understand which area I am talking about by this method? I won't be able to fill the color in this very small rectangles. You understand? We want to find the area under, exactly under this blue curve. Okay. Okay. And this is not difficult. Interestingly, the area which was easier to find by the trapezium method became difficult by the new method. But this area, otherwise we don't know how to find, but this new method will be easy because we know the equation of the curve. In that case, we found the equation of the straight line first. That was the main part of the calculation. We already have the formula for the curve, y equal to x square. And if we find the x coordinates, this is 0. If we divided this length 2, 2 is the length of the projection of this curve on the x-axis. So if we divide this length 2 by n parts, that means we are making n parts, then each width is h. So first number is 0, second number is 0 plus h, simply h. Third number is 2h, then the next one is 3h, and so on. Intermediate number is simply kh. Last number is n minus 1 times h. Because this is again the AP like 0, h, 2h, and its nth term will be 0 plus n minus 1 times common difference. So x coordinate is simply, for the kth term, it should be actually not kh, but it should be k minus 1 times h, k minus 1 times h. So how to find the height of this rectangle, kth rectangle? By putting this value of x here. This is y coordinate. X coordinate is this much. To find the y coordinate, that is the height of this rectangle, we put the value of x here. So y is found to be k minus 1 times h square. This is actually whole square. So k minus 1 whole square into h square. And so area of kth rectangle is k square, this width h multiply by this height, that I am simplifying, k square minus 2k plus 1 into h square. H into h square can be simplified as h cube into this k square minus 2k plus 1. Man, this is the limits and derivatives actually, and plus integrals. In plus one mathematics, these two parts are there. In plus two, this is there. But for physics, I have told these all things will be used from the very beginning. So that's why I had chosen for this summer program that those things to be taught which will be used in physics. Okay, I want to explain those very basic points thoroughly. So this is the thing which actually other students also have asked what we are doing. We are doing that part of maths. This part is going to be done in plus one, but towards the end of the session, towards the end of the year. This part will be done in the middle of plus two, but there is a problem with the syllabus. In physics, these things are to be used in the beginning of plus one. When you will start studying the motion of an object, you will be finding the velocity, acceleration, etc. You will be using these things. So I am actually not teaching actually physics, not at all teaching physics, but I am trying to explain thoroughly the concepts which will be used there. So we have the area of the kth rectangle equal to this. And so we can add sum of all areas of rectangles. For first rectangle, you can take k equal to 1. So 1 minus 2 plus 1 is 0. So first rectangle is actually having no height at all. So that's why its area is 0. That can be omitted, that term. But if you want, you write 0. The second term, k will be 2. So you can write this way. First term as x cube into 1 square minus 2 times 1 plus 1. For the second term, h cube is same, 2 square minus 2 times 2 plus 1, and so on. Last term will be h cube into k will be n, so n square minus 2 times n plus 1. We take h cube common. We take the square terms added separately, like 1 square plus 2 square plus and so on n square. And the middle terms taking minus 2 common, we add them 1 plus 2 plus up to n. And the last terms 1 plus 1 plus 1 n times. I write here 1 plus 1 plus and so on 1 n times. We are just near the end of the calculation. What is 1 plus 1 plus 1 n times? What it will be equal to? Yeah, who will tell? Daman, can you tell? If we add 1 to 1 n times, what is the answer? If we add 2 ones, answer is 2. If we add 3 ones, answer is 3. If we add n ones, the answer is n. And what is the sum of first n natural number? This is an AP. this number -2 is there, multiply by the number of numbers is n, so n divided by 2, first number plus last number, and what is this? The sum of the squares of first n natural numbers. You write the formula here. In +1 we will be in the chapter of AP, GP, etc. In the 10th class we have done only AP, but in the 11th class we will be doing the AP, GP, etc. So many kind of sequences. There this will be studied. This has the formula. You can note it down. The sum of the squares of first n natural numbers, that is 1 square plus 2 square plus and so on n square. This is this much divided by 6. So this multiply by h cube. So there 2 cancels, and I do the remaining calculation on the next page. You have noted up to this point. So we have this thing to be calculated, n into n plus 1 into 2n plus 1 divided by 6 minus 2 was cancelled, only n into n plus 1 was left, plus n into h cube. This is simply n into n plus 1 into 2n plus 1 divided by 6 minus n square minus n plus n cancel. I multiply h cube inside. What I do, I multiply 1h here, 1h inside this bracket, 1h inside this bracket. And here n square into h cube I write as nh square into h. So because h was is equal to 2 by n this problem, so nh is equal to 2. I put the value of nh 2. nh is 2, so this is 2 into 2, 4. 4 plus h divided by 6. It is 2 square, that is 4h. Last point, n tend to infinity, so h tend to 0. This h will become 0.